Okay, so today's lesson's on trapezoids, and a trapezoid is a quadrilateral that has one pair of parallel sides, and those parallel sides are called the bases, and it's got one pair of non-parallel sides, which are called the legs. So the parallel sides here, these guys are the bases, and then the legs are the non-parallel sides. If you've got a right trapezoid, sorry about this screen kind of crazy here. A right trapezoid has one leg that's perpendicular to the bases. So you got to pick one of those two legs and then the bases that are parallel, then you've got right angles made with those bases. Again, these are the parallel sides. Isosceles trapezoids, that's what we're going to do with mostly. An isosceles trapezoid is a trapezoid in which the non-parallel sides, those legs, are congruent. So that's going to be this. Okay, that's again the parallel symbol. So there's a whole bunch of properties of isosceles trapezoids that you probably know already, but let's kind of refresh your memory in case you don't. So properties, and these are only isosceles trapezoids that we're talking about. We know already there's one pair of parallel sides. The non-parallel sides are congruent. Diagonals happen to be congruent also. Base angles are congruent, and by the way, there happen to be two pairs of those. So base angles would be, like these guys would be base angles because they're attached to one of the bases, and then these guys up here would also be congruent because they're attached to a base. Now they're not all four congruent to each other because then that makes us to be a rectangle. So in this case, it's, or possibly even a square. But base angles are congruent. The angles formed by the same leg are supplementary. So if we had this like A, B, C, and D, then A plus B equals 180 at the same time that C plus D. Again, we are still in a quadrilateral, and quadrilateral angles always add to 360. So again, let's just kind of highlight this. So the angles formed by the same leg are supplementary. And then the last one talks about the median of a trapezoid. And if it's a median, then what that is happening, it's a line segment that joins the midpoints of the non-parallel sides. So that median is not only parallel to the bases, but it's also half the sum of the bases. In other words, it's really the same thing as the average of bases. So let me erase this for 1 second. Okay, so if we are in this isosceles trapezoid, A, B, C, D, I erased the letters, not a big deal. But since these legs are congruent, if we take the midpoints of both legs and we connect that, that means that these are all three parallel, and that, let's go maybe A, B, C, D, and then I'm going to put EF, let's say over here. And then EF is equal to 1/2 the sum of the bases. Okay, that's like the average. And there you go. So let's do some actual math and see what happens. The base of an isosceles trapezoid ABCD measures 10 centimeters and 20 centimeters. The height, the altitude is 12 centimeters. How long are the legs? So if you were to draw yourself an isosceles trapezoid, ABCD, remember you've got to put the letters in consecutive order. We know that this guy is 10, it's a shorter one. This guy is 20, it's the longer one. If we drop down the altitude, we know the altitude measures 12. Then we want to find these other sides, A, B, and C, D. Well, if you think about the altitudes, you could draw an altitude down on the other side as well. That would also be 12. But then what ends up happening is up here, this base from B to C, which is 10, also has to be the same distance from B to C here. So this guy right here, highlighted in yellow, is 10. Well, the other two parts, from the altitude to A and the altitude to D, have to be equal because we're in this isosceles trapezoid. So the whole thing was 20. This yellow part is 10, which means these guys have to be split evenly with what's left over. So these guys each have to be 5 and 5. If you just take out one of those triangles, I'll take out this one over here, which this is C and D, and we already know that this is 5 and this is 12, either by Pythagorean theorem or by knowing your triples, you can find out that CD has to be 13. 5, 12, 13. 5, 12, 13. Okay, let's take a look at the next one. Given the isosceles trapezoid ABCD with B, C, and AD parallel, if the measure of A is 4x plus 5 and the measure of D is 2x plus 15 plus 8, find all the angles. Well, the fact that A and D are sharing a base, they have to be congruent. So then you've got the equation that's going to be 4 times the quantity x plus 5 equals 2 times the quantity x plus 15 plus 8. Well, this becomes 4x plus 20. This becomes 2x plus 30 plus 8, which means 2x plus 38. Subtract 2x from both sides, subtract 20 from both sides, and x is 9. So then when you start plugging stuff in, angle A, which is the same as angle D, will plug in 9. If I do, I guess I'll go into here. A little bit shorter probably. If I do 9 plus 5, which is 14, and then I do 4 times 14, I'm going to get 56 degrees. So both of those angles are 56. Well, remember by the properties of the isosceles trapezoids, B and C have to be supplementary to A and D. So 180 minus 56 ends up becoming 124. So those angles are 124 degrees. All right, let's try the next two. Find the missing angles for x, y, and z in each of the trapezoids. Well, isosceles trapezoid here, then we should automatically know that y has to be 110, and then x and z are the supplements of 110. So x, which equals z, is going to end up being 70 degrees. Pretty easy. Next one. Should not be so complicated either. You've got a couple things happening here. If you realize, let's see, what should we go for first? We've got 98 degrees over in this particular triangle. So then we know we've got these, hold on. All right, sorry about that little slight interruption. Okay, so we're looking for x, y, and z in this particular triangle, in this particular trapezoid, sorry. If you take a look at it, you would be able to realize that these two triangles right here are congruent by S, 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 because we've got reflexive base on the top, diagonals are congruent, and it's isosceles trapezoid. So knowing that, then what ends up happening is if this guy here in yellow is 30, well, this guy here is also 30. The fact that I've got a 98-degree angle up here, its supplement is going to be 82. So to find x, all I need to do is 180 minus 82 plus 30, which means x ends up being 68. Okay, to get y, and it's actually going to be the same as z because y and z actually happen to be alternate interiors if you think about it. Parallel lines, which means this angle right here and this angle right here have to be congruent because they're AIAs. So probably the best way to do that is to realize that this whole angle right here has to be congruent to this whole angle because they're base angles. So if these guys here are 30 and 30, then these guys have to be y and y. And then what happens, you basically have an isosceles triangle. So then you would do 180 minus 98, and that gives you 82. Cut that in half, and that gives you 41. So that means, was it y? Yeah. So that means y, which is the same thing as z, is going to be 41. And there you have it. So good luck on the homework.